Hey guys, this is Mrs. Harbin, and this is your presentation for Pre-Cal, Chapter 1, Lesson 1.5, The Law of Signs. Our biblical application for today is this. We know that God made angles a part of our world. They represent a place where things come together as well as how things are oriented to each other. Unlike lines, which are infinite, angles show God's use of a finite system of measurement. Lines go on forever and ever and ever, but angles are finite. And we have lots of other finite systems of measurement. But angles are one of the most useful, and that's what we're going to be working on with this chapter. Our lesson objective for today is this. The student will prove the law of signs and solve triangles using the law of signs. Now, the law of signs can be used to solve triangles that are not right triangles. In our previous lesson, we looked at solving right triangles using all of our trig ratios and the Pythagorean theorem. But not all right triangles are right triangles. So the law of signs can help us still solve those triangles. To apply the law of signs, you must know either the measures of two angles and a side. If you recall back to your geometry days, we call this angle, side, angle, or side, angle, angle. And it has to be in that order. So the side must be between two angles, or the side must be adjacent to one of the angles and then have a second angle. Or if you don't know those two things, you must know the measures of two sides and an angle opposite one of the given sides. And we call this side-side angle. If you know one of those three things, then you can use the law of signs. In triangle ABC, where A is the side length opposite angle A, and small b is opposite angle B, and small c is opposite angle C, then the following proportion exists. Side A over the sine of angle A is proportionate to side B over the sine of angle B, which is also proportionate to side C over the sine of angle C. The law of signs can also be written like this. Inversely, the sine of angle A over side A is proportionate to sine of B over side B, which is proportionate to the sine of angle C over side C. Because we know that these are proportionate, we can use this information to help us solve triangles that are not right triangles. So let's solve triangle ABC. If A is 34, B is 76, angle B is 76 degrees, and A is 9. Now, if you take a look at this, we have side, angle, angle. One of those three things we said we needed to know in order to use the law of signs. We're going to set up our proportion, side A, which is 9, over the sine of angle A, so the sine of 34. And we're going to set that to be proportionate to side B, which we don't know, over the sine of angle B, which we do know. Now solving this then is like solving any other proportion that we've solved before. We're going to cross multiply. So we have B times the sine of 34 and 9 times the sine of 76. To solve for B, we're going to divide both sides by sine of 34. That will isolate our B. And when we've done that, we have 9 times the sine of 76 over the sine of 34. Now that we can plug into our calculator, and when we do so, we find out that B is approximately 15.6. We're being asked to round to the nearest tenth, 15.6. Once we know side B, then we can proceed to solve side A, or side C, We know the measure of angle C just by using our knowledge of triangles and the fact that angles add up to 180. And we find that the measure of angle C is 70 degrees. Using that, we can set up another proportion to solve for side C. We'll use side A over the sine of angle A and set that equal to the side C over the sine of angle C. Just like before, we cross multiply and divide to isolate the variable, in this case C. And when we plug that into our calculator, we get approximately 15.1. So we have now found all three angle measures and all three side lengths. And that is how you solve a triangle. Remember to find all the measurements of all the sides and all the angles. Side, 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 side angle, angle, and angle, side angle all guarantee a unique solution to the triangle. Side, side angle is the only ambiguous case, and you might get no solution if you use side, side angle. So if you can, use one of the other geometric terms up above. So today we proved the law of sines and solved triangles using the law of sines. If you'd like to see a full geometric proof of the law of sines, it is in your book in this section 1.5 notes. If you have any questions about how to set up these proportions to solve for non-right triangles, be sure to ask me next class.